Hello students, welcome back. We are doing chapter 23, trigonometrical ratios of standard angles. Exercise 23A, page number 291 from class 9th book of icse concise mathematics. Okay, and we have completed till question number 2 in our previous video. So today we'll start right from question number 3. Okay, so this is question number 1 of 3. We are asked to prove this trigonometrical identity. Okay, so this is the left hand side of the equation and we are asked to use this and prove this equals to 1. So let us do this. Now LHS, let me copy the left hand side of this equation. Okay, LHS equals to sine 60 degree cos 30 degree plus cos 60 degree into sine 30 degree. Okay, so this is the left hand side. We are going to use this and prove this equals to 1 equal to, so we should know the value of this trigonometrical angles. Okay, sine 60 means sine 60 is root 3 upon 2, cos 30 degree is root 3 upon 2, plus cos 60 is 1 upon 2 into sine 30 is also 1 upon 2. So root 3 into root 3, we have root 3 into root 3 in the numerator. Root 3 into root 3 is 3. Okay, root x into root x equal to x. Root 2 into root 2 equal to 2. Okay, similarly root 3 into root 3 is 3, and in the denominator 2 into 2 is 4 plus, so in the numerator here we have 1 into 1, 1 into 1 is 1, in the denominator 2 into 2, that is 4. So let us take the LCM. 4 and 4, we have 4 and 4 in the denominator. The LCM of 4 and 4 is 4. Now if the numbers in the denominators are same, then we need not multiply with any number, so we write 3 plus 1 as it is. Okay, so this will give us 3 plus 1 is 4 whole upon this 4. So 4 upon 4, we cancel this equals to 1. Okay, so this equal to RHS, hence proved. Now let us move on to the next question. Okay, let us do question number 2 of 3. So we are asked to prove this equation. In the left hand side we have cos 30 degree into cos 60 degree minus sine 30 degree into sine 60 degree. We are going to use this and prove this equal to 0. Okay, so let us prove this equation. First let us copy the left hand side. So cos 30 degree into cos 60 degree minus sine 30 degree into sine 60 degree, isn't it? So the value of cos 30 degree is root 3 by 2. Okay, into the value of cos 60 degree is 1 upon 2 minus the value of sine 30 degree is 1 upon 2 into the value of sine 60 degree is root 3 by 2, isn't it? So in the numerator we have root 3 into 1, root 3, and in the denominator 2 upon 2 is 4. Sorry, 2 into 2 is 4, isn't it? Minus, this minus comes here. 1 into root 3 is root 3. Okay, and in the denominator this is into. Okay, 2 into 2 is 4. 1 into root 3, 2 into 2, 4. So we know that 2 minus 2 will give us 0, isn't it? X minus x is 0. When we subtract a number from the same number, we get 0, isn't it? 5 minus 5 equal to 0. Similarly, root 3 by 4 minus root 3 by 4 will give us 0, isn't it? This root 3 by 4 minus same number, root 3 by 4 will give us 0. This equal to right hand side, isn't it? So hence proved. Now let us move on to the next question. Now let us do question number 3 of 3. So we are asked to prove this equals to 1, isn't it? Cosec square 45 minus cot square 45 equals to 1. So we can see the angle here, 45 and 45 angles are same, isn't it? And when the angles are same, we know the formula that cosec square theta minus cot square theta equal to 1. When the angles are same, theta theta, this will give us 1. Cosec square theta minus cot square theta is 1. This is the formula, okay? And cosec square a minus cot square a equal to 1. Okay. Similarly, cosec square 5 minus cot square 5 also equal to 1. When the angles are 5 5, okay, when the angles are a, cosec square a minus cot square a, we get 1. Cosec square theta minus cot square theta equal to 1. Cosec square 5 minus cot square 5 equal to 1. But if the angles are different, cosec square a minus cot square theta, this is not equal to 1. Okay, this is wrong. Cosec square a, angle theta, when the angles are different, then this relation is not true. When the angles are same, then cosec square theta minus cot square theta will give us 1. Okay. Similarly, we have here cosec square 45, angle is 45. Cosec square 45 minus cot square 45. When the angles are same, this relation is always true. This will give us 1. Okay. But right now we are going to use the trigonometric table to solve this question. Okay. Left hand side, let me copy the left hand side of the equation. Cosec square 45 degree minus cot square 45 degree. This is what we have in the left hand side, isn't it? Now, what is the value of cosec 45? Cosec 45 is root 2, isn't it? Cosec 45 is root 2. Cosec 45 equal to root 2. And cot 45 equal to 1. Okay. So cosec 45 means root 2. So we put square because we have a square here. Cosec square, isn't it? Minus cot 45. Cot 45 is 1. So cot 45 is 1. But we have a square here. So we need to put a square. So root 2 square. Root 2 square means root 2 into root 2. So root 2 into root 2 is 2. Okay. Root 2 square is 2 minus 1 square. 1 square is 1. 1 into 1 is 1. Okay. So 2 minus 1 will give us 1. 2 minus 1 is 1. So this is what we have in the right hand side. 1, isn't it? So this is equal to RHS. Hence proved. Okay. Now let us do question number 4 of 3. Okay, let us do question number 4 of 3. Prove that cos square 30 degree minus sin square 30 degree equal to cos 60 degree. So we are going to use this and prove this equal to cos 60 degree. Okay. So left hand side equal to cos square 30 degree minus sin square 30 degree. Okay, this is what we have in the left hand side. So let us put the value of cos square 30 degree. So cos 30 is root 3 upon 2, isn't it? Cos 30 is root 3 upon 2. So we have a square here. So let us put the square minus sin 30. Sin 30 is 1 upon 2. So we don't have a square. Oh, we have a square, isn't it? So let us put this square here. Okay. Cos square 30 minus sin square 30 minus sin square 30. So cos 30 is root 3 upon 2 and we have a square here. We put a square minus sin 30 is 1 upon 2 and we have a square here. So let's put the square. Okay. So root 3 square means 3, isn't it? Root 3 into root 3. Root 3 square is 3. Root 3 square means root 3 times root 3. So that is 3 upon 2 square. This square applies to both the numerator and the denominator. Okay. So root 3 square is 3. 2 square is 4. Minus 1 square is 1 upon 2 square is 4. Isn't it? So we have 4 and 4 in the denominator. We can take the LCM 4. Okay. LCM is 4. So when the number in the denominators are same, so what we do is we write the numerator as it is. 3 minus 1. This will give us 3 minus 1 is 2 upon this 4. So 2 1s are 2, 2 2s are 4. This is 1 upon 2, isn't it? So 1 upon 2 is actually cos 60 degree, isn't it? The value of cos 60 degree is 1 upon 2. So we are asked to prove this equal to cos 60 degree. So we use this and we proved this equal to cos 60 degree, isn't it? Because 1 upon 2. Cos 60 is, the value of cos 60 degree is 1 upon 2, isn't it? The value of cos 60 is 1 upon 2. So instead of 1 upon 2, I can write cos 60. So instead of this 1 upon 2, I can write cos 60. So this is equal to RHS. Hence proved, okay? So let us do question number 5, okay? Now let us do question number 5 of 3, okay? So in the left hand side we have tan 60 degree plus 1 upon tan 60 degree minus 1 whole square, and we are asked to prove this equal to 1 plus cos 30 degree whole upon 1 minus cos 30 degree, okay? So first let us use the left hand side of this equation, LHS. Tan 60 plus 1 whole upon tan 60 minus 1 whole square, isn't it? So let us put the value of tan 60 plus 1. So tan 60 is root 3 plus 1, okay, whole upon tan 60 minus 1. Tan 60 is root 3. The value of tan 60 is root 3 minus 1, isn't it? So this square applies to both the numerator and the denominator, isn't it? So let us put this square separately to the numerator and to the denominator, okay? A upon B whole square. If we have the number like this, A upon B whole square, we can write this as A square upon B square, okay? So A upon B whole square is written as A square upon B square. Now let us put the formula of A plus B whole square. A is root 3 and B is 1. We know the formula, A plus B whole square equal to A square plus 2AB plus B square, isn't it? So root 3 plus 1 whole square is, root 3 is A and B is 1. A plus B whole square means A square plus 2, A is root 3, A, B is 1, 2AB plus B square, B is 1, B square, okay? In the denominator, A minus B whole square, A minus B whole square. A minus B whole square is A square minus 2AB plus B square, isn't it? So what is A? A is root 3, A square minus 2, A is root 3, A, B is 1 plus B square, 1 square. So root 3 square is 3, isn't it? Root 3 square is 3 plus 2 ones are 2. 2 into 1 is 2, root 3. 2 root 3. 2 ones are 2, this root 3 comes here. Plus 1 square is 1 whole upon root 3 square is 3 minus 2 ones are 2, and this root 3 we write here, plus 1 square is 1. 1 into 1 is 1. So we have 3 plus 1, okay? 3 plus 1 is 4 plus 2 root 3, okay? Whole upon this 3 is also positive and this 1 is also positive. Plus 1 plus 3, 4, and this 2 root 3 is negative, minus 2 root 3. Now we can take the common 2 from both the numerator and the denominator, isn't it? So we take 2 common. 2 into 2, 2 2s are 4, okay? 2 into 2 is 4 plus 2 into root 3 is root 3, isn't it? In the denominator also we do the same thing, 2 common. So 2 into 2, 2 2s are 4 minus, we write here, 2 into root 3, 2 into root 3, 2 root 3. So we can cancel this 2 and 2. So we have 2 plus root 3 upon 2 minus root 3, isn't it? So let me write that. This equals to, in the numerator 2 plus root 3 and in the denominator 2 minus root 3, okay? So this is what we got from the left hand side. Now let us use the right hand side. Okay, right hand side we have 1 plus cos 30 degree upon 1 minus cos 30 degree. Okay, so 1 plus, what is the value of cos 30 degree? Cos 30 degrees root 3 upon 2, and 1 minus cos 30 is root 3 upon 2. So we take the LCM 2 is taken as LCM here. We have 1 in the denominator of 1. So LCM of 2 and 1 is, LCM of 2 and 1 is 2, isn't it? 2 into 1, 2, plus we write here 1 into root 3, root 3. And in the denominator we have 2 and 1. We have 1 in the denominator of this one. LCM of 2 and 1 is 2. Okay, so 2 ones are 2 minus 1 into root 3, root 3. So this 2 and this 2, both from the denominator and denominator, can be cancelled. Okay, so in the numerator we have 2 plus root 3, 2 plus root 3, and in the denominator 2 minus root 3, 2 minus root 3. Okay, 2 plus root 3, we write here 2 plus root 3, 2 minus root 3, 2 minus root 3. This 2 and this 2 is cancelled. Okay, because this will invert, isn't it, when we take these numbers to the numerator. Now from this relation we are asked to prove this equal to this, isn't it? So the value of this left hand side, we got this equal to 2 plus root 3 upon 2 minus root 3 from the left hand side, and from the right hand side, okay, from the right hand side when we use this, we got this equal to 2 plus root 3 upon 2 minus root 3. So the values are same, therefore we can write left hand side equal to right hand side. LHS equal to RHS. Okay, hence proved. Let's do the next question. Okay, now let us do question number 6 of 3. Prove that 3 cosec square 60 degree minus 2 cot square 30 degree plus sec square 45 degree equal to 0. So I'm going to use this and prove this equal to 0. Okay, so let's copy the left hand side of this equation. LHS equal to 3 cosec square 60 degree minus 2 cot square 30 degree plus sec square 45 degree, isn't it? This is what we have in the left hand side. We're going to use this and prove this equal to 0. Okay, so 3 cosec 60. So what is the value of cosec 60? So we have already done this in the trigonometric table of standard angles. You can check the video. Okay, you can find the table in the playlist. So let's put the value of cosec 60. So we know the value of sine 60. The value of sine 60 is root 3 upon 2, isn't it? So the value of cosec 60, sine 60 equal to root 3 upon 2. So cosec is just the opposite of sine. So cosec 60 is 2 upon root 3. Okay, so cosec 60 is 2 upon root 3. Cosec theta is the opposite of sine theta. Cosec theta is 1 upon sine theta. Okay, so cosec 60 is 2 upon root 3. We have a square here, so let's put this square, minus 2 cot square 30. So 2 we write here, this 2 cot 30. We know the value of tan 30. Tan 30 degree equal to root 1 upon root 3, isn't it? Tan 30 is 1 upon root 3. So cot 30 is the opposite of tan 30. Cot 30 means root 3 upon 1, that is root 3. Okay, cot 30 is root 3. So we have a square here, we put a square, plus sec 45, opposite of cos, isn't it? Cos 45 is 1 upon root 2. So sec 45 is root 2 upon 1, that is root 2. So this is a square, we put a square. So this 3 we write here as it is. 2 square is 4, this square applies to both the numerator and the denominator. 2 square is 4 upon root 3 square is 3. Okay, root 3 into root 3 is 3, minus this 2 we write here into root 3 square is 3 plus root 2 square is 2. Okay, so this 3 and this 3 cancels out. We have 4 here, plus 4, no sign means plus, isn't it? Plus 4 plus 2 will give us plus 6. Plus 4 plus 2 means plus 6. Okay, minus 2 3s are 6. So this is plus 6 minus 6, same number, opposite sign. 6 minus 6 is 0, isn't it? So this is what we have in the right hand side. Right hand side, this equal to 0. So hence proved, we got 0, isn't it? This equal to RHS. Hence proved. Okay, I hope you got this. Okay, this was for today. Thank you so much. Stay connected. I'll upload the rest of the questions in the next video. Okay, thank you.